Hey guys, welcome to the first lesson on fundamentals of C++ programming. Today we're going to be talking about variables. We're going to talk about how we create variables, how we give variables values, and then we'll talk about how we display variables into a console window. So because this is the first lesson in the new C++ series, I'm going to first explain what the surrounding code does, because for the most part we're going to be using this generic interface or this basic template to build most of the other examples that we do. Um, so the first thing that we're going to go over is the first line of code. So the first thing to note about this line of code is that this is considered a preprocessor statement. And it's considered a preprocessor statement because it's ran before the actual compiler comes in and compiles all the code. And we know it's a preprocessor statement because of the little pound sign that just lets us know that this will be ran before the compiler. So the actual rest of the statement is pretty much a glorified copy. It takes the content of what's in this example, the IO stream. It takes the content of the IO stream and literally copies and pastes it into this file so that we can use it. The IO stream contains code for us to write text to the console and actually retrieve text or retrieve data from the console. So by actually including that into this file, we can take that code and paste it right in here, and then we can use it anytime we want. So that's what the include statement does. The next line of code is the using namespace std. Now, in order to understand what this line of code is doing, you need to first understand what a namespace is. A namespace is pretty much just a way that we organize classes and code. Um, you can think of a namespace as a file cabinet. Inside of a file cabinet, we have separate files, right? And each file would be a separate namespace. And then within each file, then we have, other documents, or in our case, we'll have code and other classes and things like that. So the namespace is the actual file that helps us separate and organize everything better. It also allows us to have documents or code within each namespace with the same name, and then we can still access them because of the separating namespace file. So for now, just think of a namespace as a way that we organize things, and when we start running some code, I'll show you what I mean by that a little bit more. And the last part of this file is the main function. Um, I'm not going to go into details of what this is just quite yet, but I will when I do the lesson on functions. But there's a couple important things to note about this. The first thing is the main function, which is this, and these curly braces right here. This is the location where the program first begins. When the program starts, this is where the execution of the program begins, right in the main method or the main function. The curly braces right here, this is an open curly brace and a closed curly brace, just specify that anything within or between those curly braces belong to this main method or main function. This return 0 line specifies, well, I'm not going to go into it yet, but it pretty much just sends a message to the operating system saying that, this was a successful run on, like the application was successful and everything went well and everything is good. But when I talk about functions more, I'll explain what exactly this is, and we'll get into that more in detail. But the most important thing to just remember about this main function is that the main function is a unique function. It has to be with the main word, and it just specifies the location at where the program is going to start. So once the program starts, this is where it's going to start running its code, this first line. So whatever I put here, it's what the program is going to do first. So now that we have the surrounding code all covered, and obviously in later lessons I'll go into more detail of what everything is doing more, and as you learn more, it will just make sense. Um, so now that we have that covered, let's go ahead and start talking about variables. So before I can start showing you how to make variables, you obviously have to go over what is a variable. Um, so A variable is basically a named memory location. Um, First, it's a memory location because it creates a place in memory that we can store data in, right? We can store words, we can store numbers, we can store things inside of our memory in a certain location. Now, by default, all those separate memory locations that we create using variables have a memory address that is associated with them. Now, the memory address, we could hypothetically use that memory address to access that memory location and either store data and pull data from it. However, remembering memory addresses is really hard. So when we create variables, we attach a name to that variable so that anytime we want to access that variable's memory location, we can access it by the name that we created for it. And the name that we create for it is called an identifier. So every variable has an identifier or a named memory location. Another thing that is in the process that we use in the process of creating a variable is a data type. A data type is simply a word that specifies what kind of data is going to be stored inside of this variable or memory location. When we specify a data type, the memory location actually, depending on what type it is, it will be a bigger memory location or a smaller memory location, and it will also help us it'll help us to make sure that we store the right data inside of that memory location. So right now we know that variables create memory locations that have a name associated with it so that we can find it. And now we also know that a memory location has a data type associated with it that helps us control all the data that is stored in that memory location so that we know that if we're trying to access some kind of memory location, we know what data is going to be in it already before we actually get it. So knowing that, I'm going to create some basic variables so that we can see what it looks like. So a few of the basic data types that we're going to be using are, well, the first one is going to be an int. An integer is a data type um, uh, that can hold whole numbers. So an integer can, I don't know the exact range, but it's from like negative 2 billion to about positive 2 billion. That's what an integer can hold. So it can hold whole numbers. An integer or an int cannot hold floating point numbers or decimal, anything with fractions or decimals. An integer cannot hold that. A double, however, the data type is called a double, that can hold a lot larger numbers, and it can also hold decimal point numbers. There's also a bool. A bool is a data type that can hold either true or false values, so it only represents true or false. A string is another data type that can hold physical text. So like if I wanted to store the words hello world inside of a variable, I could hold that into a string. And then the last basic data type that we'll use is a character or a char, char. Um, and that holds just a single character. And I'll show you what that looks like here in a second. So the first variable I'm going to create is a simple integer data type variable. And this is what it looks like. So the syntax for creating a variable is int, that's my data type. So I always have to specify my data type first. Then the name of the variable, like I was saying before. So in this case, I'll call my variable my int, then a space. Now I could leave my variable declaration just like this and not specify a value, and I'll show you that in a second. But I'm going to specify a value here first. So I'm going to say int my int equals, and this is the assignment operator, which I'll explain in a second as well. So int my int equals, and then I'm going to specify the value that this variable is going to hold. So I'll say 15, and then this is considered a statement. So in C++, all statements must end with the semicolon, and that just tells the compiler that this is the end of the statement, or this is the end of this code. So I'll hit semicolon, and now this is a full-blown variable declaration statement. You can also see the semicolon here in this return statement, but you don't quite know what that is doing just yet. So with this line of code, we did a couple things. We created a well, when this is ran, we created a memory location called myInt. Now, don't forget that this memory location also has a memory address attached to it. This myInt is just how we access it because it's easier to remember a name that we called it. So we called it myInt. So that's what this memory location is called. We also specified that this memory location is going to be of type integer or int, so it's only going to hold whole numbers. And then we also specified the value that is currently being held inside of this variable. This assignment operator is used to assign values to variables. So what it's saying is it's saying take the value on the right of the equal sign or the assignment operator and assign it to whatever is on the left hand side. Now the only reason why I'm gonna spend a lot of time on the assignment operator is because it does get a little bit confusing for a beginner programmer when we start talking about comparison operators, because there's another operator that has two equal signs, and its job for the two equals is just to compare values rather than actually assign it. So anytime you see just a single equal operator, that's simply just assigning a value to something rather than doing any comparisons. So I'll go ahead and create some other data type variables. I'll make a double. So I'll say double my double equals 5.5. Now this works because, like I said before, a double can hold decimal point values. So there's another data type. I'll create a bool. So I'll say bool my bool, and I'll say equals true. So one thing to note about bools, which is pretty cool and interesting, is that in C++, when you assign values to a bool, you can use, if you want, true and false, and that's perfectly fine. That will assign either true or false to the myBool variable. But however, you can also use 0 and 1, and obviously 1, 2, and 3, and so on is also represents true. So if I wanted to, I could say, let's say bool b equals 0, and that's the same thing as saying bool b equals false, or I could say bool b equals 1, and that's the same thing as making a bool and assigning true to it. For the most part, I'll always use true and false, but it's just cool to note that you can use 0 and 1 like that. Coming from a language like C Sharp, you cannot do something like that. I'll go ahead and create a string. A string is a variable that can hold text, so like words, sentences, anything like that. So I'll go string, my string equals hello world, like that. And this string variable will hold this entire string. So a couple things to note here. When you use a string or assign a value to a string, you have to do in with double quotes. So you can see the quote right there and the quote right there. And by putting those, anything within those is going to be a part of the string. The reason why we have to do that is because if I didn't put it in double quotes and I just started typing, it's going to try to access elements of code. So if I were like typing, okay, my int, it would actually be trying to access the my int variable. So we have to specify that we're just entering text, so we put that into quotes. So hello world, like that. Now, I'm going to create a character variable, which is a char. I want to say my char or my char equals, and when I do a character, it's similar to creating a string, but instead of using double quotes, I'm going to use single quotes, and I only can put one letter in. So I'll store like a C, for instance, inside of my character. So characters only hold one letter or one number or only one character. Now there are things called escape characters, which I'll show you here in a second, and they they're actually more than one character, but they use the escape character sequence or the escape character, and then that performs a separate actions. And I'll show you what I mean by that in a little bit. Um, you can also, like I said before, you can create variables without actually assigning the value to it. So if I said int a and semicolon, this is a perfectly okay variable. However, I cannot use this variable until a value is assigned to it. So eventually down in my code, I could leave the variable declaration like this, and then maybe a few lines down, or it doesn't matter how long down, I would eventually have to go a equals, let's say, 6 before I can actually start using that memory location. I have to assign this value. Now, notice that I didn't re-specify the data type of the variable when I was assigning it the value. The only time you specify the value of the variable is when you're declaring the variable. This is actually the declaration for it, so anytime I access it at a later point, I don't have to specify um, the data type of the variable. I can just access it by its name and then change the value. I can then maybe later down the code go ahead and then change the value to 7 or do anything I want like that. So you can create variables without assigning the value right away. Another thing you could do with variables is you can create multiple variables of the same type at once. So I can go int a, b, c, d, and e semicolon, and now I created all these variables separated by commas at one time, and then later I can go a equals 1, b equals 2, and so on, and then I could use those. I could also um, give a value to these variables inside the declaration when I use multiple variables. I could go a equals 1, b equals 2, c equals 3, and so on, right like this, just separated um, by colons, by commas. I mean, the only thing to remember with this is that they have to be of the same data type to do this. So I want to show you two more keywords, and then I'm going to start messing with the console a little bit. The first one I want to show you is this keyword called unsigned. Now, by default, when we create these data types, they're considered signed data types. And being a signed data type just means that the value inside the data type can be either positive or negative. So my int could be negative 15 or positive 15. Now, if I marked this as unsigned, so I said unsigned int, my int, now the value of this can only be positive. This cannot hold a negative value. So just remember, signed can use either positive or negative numbers, and unsigned cannot use negative numbers. Now, however, there is a benefit with using signed and unsigned. If I mark this as unsigned, meaning it cannot have any negative numbers, it then expands, because of that, it expands the positive side. So normally, these aren't accurate numbers. Normally, let's say it goes from negative 2 billion to positive 2 billion. If you make it unsigned, it will go from 0, because 0 is not negative. It will go from 0 to probably positive 4 billion and something. So it does expand the range on the positive side if you do mark them as unsigned. Okay, so the next keyword I want to show you real quick is the const keyword. The const keyword simply just makes a variable into a constant variable. By making it a constant variable, it just means that the variable or a constant variable cannot be changed at any time. So once I mark something as a const, when I first give that initial value to it, that's what it's going to stay forever. I can't actually change the value of it at a later time. If I go ahead and try to change a constant variable by going my int, let's say equals 6, we'll see that it gets an error right here saying whatever, it can't be modified. So that's what constant means. So I'll go ahead and delete that. So we learned what signed and unsigned and constant and not constant variables mean. So let's start messing it with the console a little bit. So the console window is a window. It's just a black screen or a white screen, and it just displays basic text information. The console window is good for teaching fundamental programming because you don't have to worry about learning things that are involved with creating graphical interfaces. So that's why mostly all books begin with teaching in console windows, and I will follow that as well. So I'll always create lessons, well, at least in the beginning lessons, I'll create all my lessons using console windows because, like I said, it really makes it easy to learn the actual principles of programming rather than have to worry about using graphics. So the console, um, to use the console in C++, it's a little different if you're coming from Java or C Sharp. Using the console in C++, we used a couple keywords, and these keywords or objects are living in the standard namespace. So that's why we, in the beginning, we said using namespace std, which stands for using namespace standard, and that just allows us to access the code in the namespace standard without actually having to specify the namespace every single time we want to use it. So I'll show you what I mean by that. So to start off with, if we wanted to display things to the console, we use the cout object. And so that looks like this, cout. So then when we want to see out something or display something to the console, we have to use the insertion operator. The insertion operator is two less than signs, so less than, and that's the insertion operator. And then we can go, let's say we want to display a string, so we'll say hello world as a string in double quotes, like that, and then semicolon. Now before I run this, I want to explain a couple things. If you're coming from C Sharp, the insertion operator is similar to using the concatenation plus operator. When I start adding more things and concatenating with that, you'll see the similarities between that. Also, when we use the cout, and we write to the console, we're writing to the console output stream. So it literally just gets written right into the stream without any extra things, only what you specify. So when I run this, if you're coming from C Sharp, you're used to, if you're using the write line method in C Sharp, it normally always writes whatever you want and then goes to the next line. Well, this is similar to the write method in C Sharp, where it keeps everything on the same line. So you'll see when I run this, it's going to display hello world, but it's not going to show anything on a new line, so everything's going to be like bunched up right after that. So if I run it, you'll see it says hello world, and then it says press any key to continue right after that. So no new line was added. So I'm going to show you two ways that we can add or go to a new line in this. So the first way, we're going to use the endl, word or keyword. So to do that, after our hello world in our quotes, we're going to do another insertion operator, because we're going to insert something, and then we're just going to insert the word endl, and that just means end line. So when I run it now, we see that the hello world is on its own line, and then endl brings it to the next line. So if I were going to start doing another cout down here, and just doing hello here, we'll see that it'll go to the next line and then write hello, and then once again we have the problem on the next line. But it just shows you that the endl brings the console stream or the stream to the next line for writing. Another way we could do a new line is by using the new line escape character. So we can just go inside of, so escape characters are used within strings. So if I wanted to add a new line, I just go inside of the string. Wherever I want to do a new line, I go backslash, that initial, or that starts the escape, that is the escape character starter. And then I do my escape character. So in this case, to do a new line, we use the n, and that means just go to a new line. So backslash n is an escape character for a new line. So I run that, we'll go ahead and see that the same result happens. It goes to a new line. You can look up a list of escape characters. They're really basic. Some of them are like tabbing and beeping and things like that. So this is the new line one. So that's the basics with writing to the console stream. So let's go ahead and start plugging in some of our values of our variables, because that's what variables are for. They hold values, and then we can use and manipulate them in any way we want. So if we want to display the values of them into the console, this is what it will look like. So the first thing we're going to do is cout insertion. Let's add some text. We'll say the value of my int is equal to, we'll put that all in text. We'll close our dialog quote. So this is our string literal right here. This is our string. And then we're going to plug in or concatenate using the insertion operator the value of my int. So we'll use another insertion operator and we'll go my int semicolon. Now once again, we don't have a new line operator here, so it will all get bunched up. So if we want, we'll go ahead and just do end L as well. So this should be good. So this should display the value of my int. If we run it, we see my int equals -15, and right there, my int equals -15. So that's just displaying some values. I'll go ahead and display some more of them real fast, just so you can see what it looks like. So we'll say my double equals, and we'll plug in my double, and L, we'll do some C out. My, I don't want to do that yet. We'll do my string um, equals, and we'll plug in my string right there, and then end L. So let me run this real fast. Hold on. Okay, why is this erroring? Oh, okay. So I forgot one include statement. In C++, we need to include when we want to manipulate and use strings, we need to include this include statement for string. So up here we'll go ahead and say include string, and that should fix the error. Yeah, okay. So it's just when we want to format the string inside the console and display it, we need to include the string to use the correct string. Um, string stuff. All right, so let's go ahead and run this. All right, so we can see it says my int equals -15, my double equals 5.5, my string equals hello world. Okay, so that's just displaying some of the variables inside of the console. Okay, so the last thing we're going to do with this in this lesson is um, we're gonna pull in a value that's entered into the console. We're gonna pull that in and then store that into a variable so that we can use it at a later date. I'm just gonna show you the basics with pulling it and storing it into the variable and then redisplaying. In the next lesson, we're gonna start talking about arithmetic operators, and we'll use this technique to build a simple calculator application inside of the console. So let me go ahead and delete this. I'm going to go ahead and say int my int, and I'm going to say semicolon. I'm not going to assign it a value just quite yet, because I'm going to wait to the console when they enter it in, and then I'll display or assign it a value, not right now. So I'm going to go cout, enter a value for my int, \n, so we're on a new line. And then I'm going to go cin. I'm going to use what is called the extraction operator, which is 2 greater than signs, and then just say my int. So what this is going to do is it's going to wait until a user enters in something that can be stored into an integer, and then we're going to extract that and store it into the my int. So we said cout, enter a value, and then we store it into my int using the extraction operator, which is right here. And then finally, we're just going to redisplay it to show you that, or to really show you that we have it stored inside our variable. We're going to say the value of my int is, and then we're going to go ahead and plug that in, saying my int, and then end L. So let's go ahead and run this. So it says enter a value for my int. I'll say 5. And then it says the value of my int is 5. So this just proves to you that when we use the extraction operator and pulled it in, we actually have the value stored into our integer variable, and then because we can redisplay it inside this next line. Okay, so that's it for this lesson. So next lesson we're going to pick up with using arithmetic operators, and we're going to talk about how to do like adding, subtracting, things like that, and then we'll build a simple calculator application in that lesson. So thank you for watching. I hope you guys enjoyed.